Assalamualaikum and good day everyone. In chapter 5, we will learn on measures of variability. These are the objectives. We are going to learn how to find the measures of variability or dispersion for both ungrouped and grouped data in terms of range, interquartile range, variance, and also standard deviation. The measure of central tendency that you have learned in the previous chapter, which is the mean, median, and mode, gives only partial information about a data set. So that's why in this chapter, we also need a measure that can provide some information about the variation, the variation. In other words, the dispersion or spread among data values. Okay, it is how to describe how much the observations differ from one another. For example, if your nature guide told you that river ahead average 3 feet in depth, would you want to wade across on foot without additional information? Okay, well, 3 feet is quite, the depth is considered dalam lah kan. Okay, so you must know other information also before sebelum awak cross sungai, menyeberang sungai tu. Okay, now let's see this example. The following table gives 3 different samples with all have same mean and median, which is 45, but have completely different spread. Okay, you can easily calculate the mean. Okay, by using the formula that you have learned in the previous chapter, okay, you will find the summation of all divide by the sample size. Okay, so you can check on sample 1, sample 2, and sample 3. You will get the mean and also the median 45. Okay, this is for ungrouped data. Okay, 3 common dispersion measurements are range, interquartile range, and finally variance or standard deviation. For variance and standard deviations, once you can calculate variance, you will easily get the value of standard deviation, because standard deviation is the square root of the variance. Okay, first let's look at range. Range is the simplest numerical measure of dispersion. Okay, for ungrouped data, you will simply do maximum minus minimum. Okay, that means whatever largest value minus the smallest value. That's for ungrouped data. Okay, while for group data, it will be upper limit of the last class minus lower limit of the first class. Okay, in general, more dispersion will be reflected in a larger range. However, dispersion is a characteristic of the entire data set, and each observation contributes to dispersion. Okay, some disadvantages. Dispersion can be influenced by outliers, and also they only consider 2 values. Okay, in the case of ungrouped data, when you calculate range, it's only involve the largest value minus the smallest value. Meanwhile, for group data, you will only consider the upper limit of the last class and the lower limit of the first class. Okay, the following table presents the average monthly temperature in degrees Fahrenheit for the cities of San Francisco and St. Louis. Compute the range for each city. Okay, so for San Francisco, the highest value is 63, and then the smallest value is 51. Okay, so the range for San Francisco will be 63 minus 51. Okay, that's 8 degree Fahrenheit. Okay, meanwhile, the range for St. Louis, the highest degree is 79, right? And the lowest temperature is 30. Okay, so this is 49 degree Fahrenheit. Okay, as you can see, the data for St. Louis is more dispersed than the data for San Francisco because of the range value is bigger for St. Louis. Belas 63 tolak 63 minus 51 is 12 degree Fahrenheit. Okay. Okay, the interquartile range tells us how closely the values of a data set clustered around the median. It is the range of the middle 50% of the data. Okay, so it's resistant to the effects of outliers, defined as the difference between the first quartile and the third quartile. So the formula for interquartile range is simply third quartile minus first quartile. Okay, quartiles are measures that divided a ranked data set into 4 equal parts. Okay, so the whole part will be 100%. So as we divided the set into 4 equal parts, so that means 25% each. Okay, you can read the points here. Okay, now let's see how to compute quartiles for ungrouped data. Okay, we will look at computing quartiles for group data soon. Okay, first, arrange data in ascending order. Find the depth of Q1 and Q3. Okay, this is the formula for depth of Q1 and depth of Q3. And then determine the values based on the position. Okay, this is not yet the value of Q1. This is only depth of Q1 and depth of Q3. Only then you will determine what is Q1 based on the depth. Okay, or what is Q3 based on the calculated depth. Okay, just like when you are trying to locate the median, okay, you need to find the depth of median first. Only then you can find the median value. Okay, following final exam scores arranged in increasing order for 28 students. Okay, find the first quartile of the score. Okay, first quartile depth of Q1, okay, is n plus 1 over 4. So that is 29 over 4. Okay, and we will get 7.25 TH. Okay, this is only the depth of Q1. So 7.25 is between 7 and 8. Okay, 2, 3, 4, 5, 6, 7. Okay, so this is the 7th data and this is the 8th data. Okay, so how are we going to calculate uh, 7.25 how are we going to calculate Q1? Okay, so Q1 is, okay, first we will write the 7 data values, which is 69. Okay, and then plus the remaining 0.25 times the difference. Okay, 71 minus 69. Okay, and then use your calculator. Okay, then we will get the value of Q1 is 69.5. Okay, and then you do the same thing for Q3. Okay, depth of Q3 is 3 over 4 and plus 1. Okay, so this is 3 over 4 times 29. And that is 21.75 TH. Okay, once again, this is only the depth of Q3, not yet Q3. So what is Q3? Q3 is, okay, what is the 21st data values? Ni 14, 15, 16, 17, 18, 19, 20. 21. Okay, so this is the 21st and 22nd. Okay, as you can see, 21.75 TH must be between the 21st and the 22nd data. Okay, so Q3 equals, okay, first write the 21st data, which is 82 plus the remaining value here, 0.75 times the difference. Okay, 84 minus 82 is 2, and we will get Q3 equals 83.5. Okay. Okay, now we have both values of Q3 and Q1. So determine the interquartile range. So interquartile range will be Q3 minus Q1. 83.5 minus 69.5. And that equals 14. Okay. Okay, now for example 2, I hope you will try on your own. Determine the interquartile of the data. Okay, you can check the answers here. Okay, Q1 is 79.5, Q3 is 102.1, and finally the interquartile range value is 22.6. Okay, although the range is easy to compute, it is not often used in practice because it involves only two values from the data set, the largest and the smallest value. And then the measures of spread that are most often used are the variance and the standard deviation, which use every value in the data set. Okay, when a data set has a small amount of spread, like the San Francisco temperatures, most of the values will be close to the mean. When a data set has a larger amount of spread, more of the data values will be far from the mean. The variance is a measure of how far the values in a data set are from the mean on the average. The variance is computed slightly differently for populations and sample. Okay, so be careful um, with the formula later on. Okay, in the formula, the mean mu is replaced by the sample mean, and the denominator is n minus 1 instead of n. Okay, um, for population, you will divide by the population size, but for sample variance, you will divide by n plus 1. Okay, for population it's solid n, but for sample it's divided by n minus 1. Okay, these are the formulas for this is for ungrouped data. Okay, the variance for ungrouped data, and this is the formula for group data. Okay, once again, be careful when you are dealing with group data is the one with the frequency value. Okay, and then for ungrouped data, you only consider for you do not have anything related to frequencies. Okay, in example 1, you can see that data on a company that manufactures batteries. Testing a new type of battery designed for laptop computers. Okay, they measure the lifetimes in hours. Okay, so this is battery lifetime in hours. Okay, and obviously this is ungrouped data. Okay, because it's not listed in a frequency distribution table. Okay, find the variance of the lifetime. So in order to find the variance, the symbol for variance for sample is small letter s squared. Okay, so this is variance. Okay, once you are able to calculate the variance, the standard deviation will be easy. Okay, the standard deviation will be simply the square root of s squared, or simply s. Okay, and the variance is 2. Okay, and then in the next example, we have group data. Okay, because we have data group according to classes. Okay, so this is group data, so you must use the formula for group data. Okay, you must have class midpoint. Okay, x in the formula is class midpoint, and then you will add another column, frequency times the class midpoint, and also another column of f times midpoint squared. Okay, I would always recommend you to use Excel so that you can easily auto calculate the values for each column. Okay, because the variance is computed using squared deviations, the units of the variance are the squared units are the squared units of the data. Okay, in most situations, it is better to use a measure of spread that has the same units as the data. We do this simply by taking the square root of the variance. This quantity is called the standard deviation. Okay, the standard deviation of a sample is denoted by S, and the standard deviation of a population is denoted by sigma. Okay, it is very common in statistics. The symbol used for population will be using Greek letters, while the symbol for sample we will use alphabet. Okay, whether it's small letters or uh, capital letters. Okay, these are the important properties of standard deviation. The standard deviation is a measure of variation of all values from the mean. The values of the standard deviation is usually positive. The value of the standard deviation can increase dramatically with the inclusion of one or more outliers. The units of the standard deviation are the same as the units of the original data values. Okay, the following table is the two set of mathematics marks from an examination. Okay, for each data set, find the range, find the variance and standard deviation, find the interquartile range. And okay, so please do this on your own. And you can compare with the provided answers. Okay, and then this is the next question. Okay, conclusions, measures of dispersion. Okay, you can see all the formula listed here. Okay, so that's the end of this chapter. Thank you so much.